Hey guys, welcome back to another video and welcome back to the channel, the IB Dose. And once again, I am going to be referring to you guys as the Dosers because it's a really cool name and it does not refer to people taking drugs. Anyway, let's get started on today's video. So today we're going to be going over solving quadratic inequalities. So there are two ways you can do this. One is the algebraic method, so algebric, and one is using a sine table. So we're going to be tackling both, as I did not go over that in the last video, so I'm going to be going over it today. So let's get right into it. So first we'll talk about the algebraic method. You can read the definition, you can read the explanation given over here. That's just for your own convenience, but I'm going to be explaining it myself. So the algebraic method is basically using factorization or using the quadratic formula. So you can use both over here to solve a quadratic inequality, and it'll make more sense once I go through the problem. So let's move on to the problem. You guys can pause the video and read the explanation if you want. So here we have a quadratic inequality. It's 2x squared minus 5x minus 3 is greater than or equal to 0. So once we have this inequality over here, we realize that this is a quadratic equation, obviously. Yes, this is a quadratic equation. I want you to ignore this for now. So what's the first thing that you would think to do over here? Well, I would think if I need to solve any quadratic equation, I will always start off with factorization. I would assume that I don't have a calculator and I would not try to use a quadratic formula because it's just long and painful, man. It's the story of my life, honestly. Anyway, yeah, so quadratic factorization, that's what we'll go with. So over here, you realize that 2 times minus 3, so it has to multiply to get minus 6 and add up to get minus 5, right? So you can realize over here that it can be 2x plus 1, x minus 3. Yes, that's what your factorization would look like if you did factorization. So I just factorized it really quickly for the benefit of the video. So I just factorized it really quickly, and this is greater than or equal to 0 because these both are still the same. So now we realize over here that we have two roots that are given over here. Again, roots are when the parabola, the quadratic, or any single function intersects the x-axis. So when y is equal to 0. So when y is equal to 0, how would you make y equal to 0? So if you plug in x is equal to negative half, you get 0, because this would become 0. 0 times this, no matter what this is, it would be 0. And x is equal to 3. So x is equal to 3, this would end up being 0, and this multiplied by that, it would also end up being 0. So these are your two roots roots of your quadratic equation. Yes. So now you have to figure out how how to like organize and how to think about it in that way. So you have to think, okay, so I have an inequality and it has to be between these two factors. So it has to be between these two. So how would I represent that in a quadratic in an inequality form? So I want you guys to think about that real quick, if you can. So the way I would think about it is, because those two are the roots, you'd have to sorry, I'm getting called. Yeah, you'd have to think about, okay, between these two roots, that is where it's greater and it's that. So this is a concave up. Yes. So concave up means it's something like this. Yeah. And it's asking, when is the inequality greater than or equal to 0? So that means that at the roots, yes, okay, fine, they're equal to 0. These are your two roots. Yeah. So this would be 3, and this would be minus 1 half, 1 over 2. Yeah. And those would be your two roots. So that means that everything below here is less than 0. And you do not want that. You do not want y to be less than 0. So over here, you realize that everything after minus 1 half, everything after here, everything after here, and here is all positive for y. It's greater than or equal to 0. So with that, you can simply write x has to be less than or equal to, because it's still less than or equal to, minus 1 half. So that means anything after 1 half is greater than or equal to 0 for y. And for 3, it can be 3 because it's greater than or equal to 0. So that would give you 0. And everything after 3. So x has to be greater than or equal to 3. And that's how you'd solve it, because due to the inequality saying that it has to be greater than or equal to 0 for y, every single y value has to be greater than or equal to 0. So it means this and that, these two. You ignore this part because it's less than 0. And this is the mark scheme for it. You can go through it. This is just another way of representing exactly what I've written over here. But you can write it in this way. It goes from negative infinity to this. And these brackets here, they basically mean including. So it means the difference between this and this is this would be greater than or equal to. This would be just greater than. That's the difference. That's the difference between these two. So I just want you to understand that real quick. And this is just another way to represent your final answer. But you can do it in both ways. So let's move on to trying to solve the same inequality, but this time with a sign table. So we still do the same thing. We still factorize to get our roots. Yes, 2x plus 1, x minus 3. It's greater than or equal to 0. That is our equation. Yes, that is our factorized equation over here, and that's fine. We just do that for now. That's our first step. And now a sign table, essentially what that looks like is something like this. So x, f of x. This is negative infinity over here. Okay. Negative infinity. Negative 1/2. 3. These are your two roots. And infinity. Yeah? So we just draw a line down here, draw a line down here. So we know that f of x, which is essentially our y value, yeah? F of x is our y value. We know that negative 1/2, when x is equal to negative 1/2, y will be 0. So this is 0. And at 3, x is equal to 3, f of x will also be 0. So this would also be 0. So then after that, we know that this is again, we refer back here, so concave up. Yes? So everything after the roots, everything after here, after our two roots, is positive. Yeah? So this would be positive. This would be positive. Now there's a rule. If this is positive and this is positive, the in between, it would be the opposite sign. In between the roots, it would be the opposite sign of what it is outside. Like, think about it. Anything between minus 1/2 and 3, this region of your parabola, would be negative. That y value would be negative. So that's how you determine what sign is between your two roots. So there we go. I hope that makes sense now. It's really simple to use a sign table. You can do both methods if you want, but it's really simple to use. And it's really convenient in some situations when you have like a really complex quadratic equation with multiple inequalities to solve. So I hope you liked today's video. I kept it short, somewhere around 5 minutes, hopefully. Oh no, it's 8 minutes actually. So, it's always too long, man. That's what she always says. You know? Anyway, sorry about that. I hope you enjoyed today's video. I will be posting the Canva slides in the description below. So do check that out if you need some referring to some notes or something. And I will be posting Calendly link once again for tutoring one-on-one. And again, since this channel is just starting out, I will be hosting free tutoring sessions for anyone that books a class with me. So go ahead and please book those sessions. Thank you so much for watching. Have a good day.